So what I'd like to talk about today is a little bit about server management and then infrastructure management, right? We've got all our Windows servers that need to run. Infrastructure is how they're all connected together. I want to drill down into some application specifics, right? We stand up servers to be able to run Epicor. That is our application. It requires a lot of underpinnings. Change management, I brought this into today's presentation only because it's caused issues recently for some of our clients in the past. And so I wanted to just mention what is change management and how do we get all the people involved in doing that. And then now that you have all of your servers and infrastructure and applications, you have choices as to where to run that. So I thought I'd bring up where do you put your server and some best practices around that. So without further ado, let me dive right into our server management section. And we want to identify first off that when we talk about servers, most ERP solutions run as a three-tiered model. Now, back in the old days, for example, P21 legacy environment only ran as a two-tiered model. And what that would mean is that we have our databases running on one stack. Typically that equates to a server. We have the application running as a server. In this case, the E10 environment is most typically deployed, at least appropriate to our audience here. And that's going to be where IIS runs, and that's where users have, where the users don't interact directly with the application model. Users have a user interface. That's going to be your Epicor client's application. That's going to be the P21 application. In some cases, that user interface is a fat client where we have to install an exe. It could be a thin client like a web browser. And there's a couple of layers and possibilities in between there, but that user interface is where the user sees the application run. The user doesn't deal with the app servers. The user doesn't deal with the database servers. So when your users see this solution, know that they're interacting with kind of the third layer of this interface. And when we're trying to figure out what's going on with your servers, we have to deal with the database layer, the application layer, and the user interface layer. So there could be a number of different ways that you choose to deploy this in your environment, depending on the size of the deployment, how big it needs to scale, how available it needs to be. You might very well glom these things onto different boxes. So one option is to put your database and application layer as part of a single operating system. Not recommended. In fact, Epicor says in their E10 environment, only if you're on a physical server can you put SQL and Epicor on the same box. I have seen clients do this in the virtual world, but Epicor won't support your E10 environment as a single operating system. Now, in the P21 space, that can be done. Again, not recommended to put your SQL application as well as your P21 application in the single OS. It's really not scalable, and they have different performance requirements. So you end up with a lot of things going on in a single OS that can be difficult to troubleshoot. So often our clients use three separate servers or three separate farms where the SQL server is one box, the application server is another box, and the user interface, whether it's the user's workstation or you use something like terminal services to deploy your applications, those are typically done in three separate layers. In fact, when we deploy our cloud solutions, we use that three separate servers or three separate sets of servers. Now, if you're the type of client that is a purist and you absolutely have to have tests completely separate from production, you might find that you have 6 separate servers or 6 collections of servers, 3 for the production environment, 3 for the test environment, and in the purist model that makes sense. However, in the real world, we have things like time and money that come into play. So what we tend to do is we tend to combine some of these functions together. So I see this frequently where we have one SQL server for both production and test. Different databases, maybe different instances, but one SQL server is a whole lot cheaper to license than multiple SQL servers. But if your licensing comes easy to you, the budget is there, you might decide to have 2 separate SQL servers, one for production, one for test. Common RDP servers. Again, RDP can be an expensive animal to set up, both in terms of time and money. So what we see is a common set of RDP servers on those remote desktop servers. RDP is remote desktop. Some of you might call them terminal servers. We stand up an icon for the users to run production. We stand up another icon for the users just to run and test. And then typically what we do is we have separate application servers, because the Epicor application is the biggest, arguably most complex scenario here, layer in the stack. If we have one test server for E10 and another test server for another production server for E10 or P21, that way we can separate the animals, so to speak, and having those separate application servers allows us to deploy new upgrades, new environments. What happens when I patch Windows? What happens if I try and restore Windows? With a separate application server, we can do all of that in test without impacting production. So we see lots of different combinations, and it really depends on your requirements for independent testing versus production. Okay, so with that, then we have all of these servers certainly need their place to live and be managed. And so when I look at what does that imply in terms of each individual server, right? Each server obviously has hardware resources. And most of our clients at this point are in the virtualized world. So adding or removing these four main components is easy to do. I do see a lot of clients that will just say, oh, solve the performance problem by over-committing memory. Just add more CPUs, for example. That'll make it go faster. And that's not always the case. In fact, we've seen a lot of places where if you over-commit memory or overcommit CPU, it will actually hurt your performance, because the VM has, or the hypervisor, excuse me, has to schedule all of those resources. And there's things that we can overcommit CPU and create SQL licensing problems. For example, SQL is licensed usually, not always, but usually by core. So if you give your SQL server 4 cores, that's the minimum number for SQL for Microsoft to be happy in SQL licensing. But if you give it 8 cores, you've just doubled your licensing requirements. And if you ever have Microsoft come down and audit you, as happens to us every couple of years, they're going to look at how many cores do you have presented to SQL, and you had better have that many licenses applied for your SQL server. So if just by adding CPUs, you can easily double your licensing costs. So be aware of that. We can certainly bring that conversation up more in the Q&A session. Likewise, with overcommitting memory, that creates a problem with hypervisors and this thing called memory ballooning, where if you give it more memory than is available, the VM gets the memory, but it hurts because the hypervisor's got to figure out how to deal with all of these VMs and how much RAM they need. The other challenge we see in hardware resources is networking aspect. A lot of our clients, they plug their servers together with an Ethernet switch. That Ethernet switch might be shared with other components. The clients obviously need to get into this environment, but we need to look at the networking aspect, that we don't want to overload one network card with the traffic that's going between those 3 different layers. In some cases, we've seen it's better to create a dedicated network for the SQL to application server and another network from the application server to the user interface. And we only see this in high bandwidth environments. So if you're running less than 100 users, typically we're not going to worry too much. With just 100 users, you're not going to see that level of I/O necessary to start creating dedicated network cards. In fact, I've seen smaller environments where the engineer or the technicians will over-engineer the solution. And I don't want to say this too loudly, because I've seen this happen even from the big guys themselves, Epicor, where they will over-engineer a solution, and they'll have you stand up 5 servers for a 50-user or 100-user solution. And in my opinion, 5 servers, while that's certainly doable, it might be overkill for your environment. We've been involved in a number of different upgrade solutions where the clients have said, you know, I had 4 servers running and I'm only 50 users. That's a whole lot of time and money. Can we consolidate that? Absolutely. Typically, you don't need a separate task server and a separate application server and a separate web server, although I've seen, again, over-engineering occur. So in general, when we stand up an Epicor solution, we start with this thing called the hardware sizing or the hardware recommendations guide. Basically, what this tells you is if you have this number of users, in general, you want to have this number of servers, you want to have this much RAM, CPU, etc. And what I do is I start with that guide as a baseline, and then I tune from there. Now, tuning can be tuning up or tuning down. And it's not just a blind dial that we spin up. Again, adding too much resources to a given machine can actually hurt the performance of the box. But we'll look at that and decide what layer is getting hit. We use performance monitor. We have a lot of RMN tools that we use to see, what needs more or what needs less, and we tune from there. So for example, we've got one client that runs 60 users on a single terminal server, and it worked great with the 32 gigs of RAM. I think we had 8 processors in that machine in that terminal server, and then they did something fancy and they upgraded to Epicor 10.2.700. And as soon as that new application got installed on the terminal server, lo and behold, it was not enough memory anymore. That new version of Epicor requires a little bit more memory for the user interface. So we had to upgrade RAM. Fortunately, we were watching that. We were ready for it. So when the upgrade occurred, it wasn't a total surprise that the server started running low on memory. We were ready with some more sticks of RAM. I'm being facetious. We don't deal with sticks of RAM anymore. We just allocate more RAM as part of the hypervisor. And we tuned up based on the upgrade of their Epicor application. So we're looking at these things as different recommendations. The end of the game is always monitoring and measuring to make sure what you have is properly tuned and responding appropriately for the end user. Now, there's a number of different things that we have here in the server management role that come into play when we look at these servers. Now we've stood up these servers. We started with the baseline recommendations from Epicor, our experience, and now we're starting to monitor and measure from there. Now, before I get too much further into the how do we keep these things running smoothly, I needed to throw in a slide about security. Because for any of you that have seen me get up on my soapbox before, security is something that we kind of bake into the architecture. Don't layer security on as an afterthought. Don't put it on after the system is running. Whenever you try and tighten screws on a running system, stuff breaks. So my recommendation is to I'm going to talk about these couple of bullets here, but make sure you bake them in at the beginning of your project. And if you've already got your Epicor server up and running, then just be aware that tightening these screws is going to likely over tighten, and you're going to have to either back off or reapply them. That's one of the great reasons we have test servers, right? Testing servers allow us to mess around with things like security and not impact the production environment. So let me go over these 4 bullets here and just make sure that you've got a plan for these in your architecture. The first one, without a question, is your disaster recovery. People go, well, how do I back up? How do I restore? How do I make sure that if something blows up, I can bring this thing back? And the answer to that question is specific to each client. All that I know is that you should be able to go through your Epicor architecture from the SQL server through the application server to the terminal servers to the users that are connected up with their desktops. And you should be able to point to any device and go, well, what happens if that device turns into a smoking crater in the ground, right? It might turn into a smoking crater because you did a bad Windows update, or Microsoft did it again, right? Microsoft, by the way, for anybody running E10, you probably learned that last month when Microsoft released a patch that brought Epicor performance to its knees. If you haven't seen that, good. Maybe you just haven't installed the patch yet. And maybe you caught it and you prevented that patch from installing. I forget the full KB number, but it ends in 1319. So if you have your Windows servers and you're about to apply Windows patch something 1319, you might want to put a hold on it and test it first. You also need to be able to do this disaster recovery testing because occasionally stuff breaks, right? Networking is usually pretty reliable, but the Windows operating system, the SQL operating system, disk drives, these kinds of things break. And so being able to do your disaster recovery testing so that you can measure your recovery point objectives and your recovery time objectives. I've talked about this a lot in the past. Recovery point is how much data can I afford to lose? At what point in time do I fall back to in the case of a disaster, right? You ask the boss, they want to be able to restore to the last 5 minutes. We can do that. You just got to plan for it. Some folks back up nightly. And if you only back up your servers nightly, then and the server crashes the following night just before your backups, you might lose 24 hours of data. So recovery point objectives or something is a number. Ideally it's going to be something small, 15 minutes. Maybe I can lose an hour of data, but 24 hours of data might be really detrimental, especially if you've got a lot of users entering orders and things like that. The recovery time objective is how much time can you be down? Okay, so if your server blows up and blue screens, how much time is it going to take you to restore that server and get it back up and running? So these two numbers, the RPO number and the RTO number, are going to come into play because when your server crashes, and I say when and not if, because really it's just a matter of time before Microsoft does it to us again, or your disks fill up, or you didn't realize that you shouldn't format C:, those kinds of things happen. The fires burn brightly. The boss is on your back and they're going to say, when's it going to be back up? And if you've never done a disaster recovery test, you'll go, as quick as I can get it there. But without knowing that number, you can't really provide to management those specific numbers, because when you tell them, well, we might lose 24 hours of data, and I've never done a disaster recovery before, so if it takes you less than 3 days to bring your server back from bare metal because you've never done it, 3 days is not a bad RTO. Now, you might not be able to afford to be down for 3 days. I get that, right? Especially if it's the busy season, right? Around Christmas time, orders pop up faster. The end of month, the accounting's got to get month end done, those kinds of things. So if your RTO is not allowed to be 3 days, maybe your recovery time objective should be something more realistic, like 3 hours. You got to test it, because until you test it and you go, wow, it took me 3 days to restore that server from last night's backup, that's when we start looking at better tools to do the DR testing and to reduce your RTO and RPO numbers. But make sure you test that. If you take nothing out of today's webinar, test your backups. Okay, moving on to the next one. I think I've beat that horse to death here. Next one is all about patching. You're going to have to plan to patch. There is no such thing as never patching. Well, there is, but then you become less secure for it, because patching your servers, not only does it fix problems, but it keeps your security measure up. So you need to plan for maintenance windows. Make sure that you can, if there's a Sunday night that you can take your servers down, patch them and reboot them. And oh, by the way, if they don't reboot properly, make sure those disaster recovery tests have already been run, because you might have to declare a disaster after you install patch 1319. It will break your servers, make them really slow, things like that. That doesn't blue screen them, it just makes them slow. And you might have to fall back. So, we do the patch on 9 o'clock Sunday nights, and by 11 o'clock, we've determined whether or not this is a roll forward or it's a fallback policy. And just make sure that everybody's kind of on standby. So if you have to do a restore, it's not going to be a scramble to find the right resources to get that restore done. Resources both in terms of hardware as well as people. So patching is an important part. Now, some folks don't like to patch their Epicor solution, because when you patch Epicor, Epicor moves your cheese, right? It changes processes or functional processes on how the system runs. So we're going to make sure that we have the appropriate regression testing so that the users can know what's going to change when you go from Epicor, 10.2.500 to 10.2.700, for example. The patching of the operating systems and the SQL servers, the end users never see that kind of stuff. They just know that you took it down, it's back up, they're good. The next bullet I want to talk about, of course, is malware protection. You need to protect against malware, and that actually means that you need to run antivirus. Now, if you're running server 19, you're already running antivirus because Microsoft provides that in the operating system, right? Windows Defender was built in there. Now, unfortunately, Microsoft doesn't know about Epicor, so make sure that you check your malware exclusions. You don't want to be scanning your SQL databases for malware because it's going to kill performance. You probably don't need to be scanning your IIS temporary ASP.NET logs because it'll kill performance. And even the operating system itself, where if you're installing third-party malware protection, please make sure that those exclusions for the OS, for SQL, for IIS are all in place. If you need to know what they are, you can look at my blog article. I've got a couple of entries on there, and there's a lot about the Windows, SQL, and IIS exclusions that should be up there for malware protection. Likewise, the Epicor server application, there are some exclusions there. You have an Epicor data folder if you run E10, for example, and that should not be scanned for malware. It slows down the performance too much. And the Epicor client, similarly, while many folks disregard this, the Epicor client uses temp files. It uses a area on the local hard drive, and there are some potential exclusions that you want to have there on the client-side application, just so that, yes, you have malware protection, but no, it's not killing your performance. Also, last bullet there under malware protection, it's a verbal, not there in the slide deck. Make sure that you don't have two antiviruses running. I've seen this happen a lot where the machine came with McAfee and you decide to install Symantec. Don't have them both running at the same time because the machine will die under performance. It will kill the performance. So have one antivirus tool, stick with it, do the proper exclusions, and there you go. I did saw a QA there from the chat line. The answer is, yep, 460.13.19. That was the latest patch. Came out in February. Most people, when they do their patching, they wait a little while, or at least they wait a while to put them on their production servers. You can certainly be more aggressive on your test servers, apply your patches, and you would have seen that 460.13.19 did indeed affect performance, and that's why we didn't push it into production. Okay, so last bullet is under account best practices. All right, Epicor uses accounts, whether they are Windows accounts or they are SQL accounts. They all use accounts to be able to get their job done. In a domain model, they typically are domain level accounts. And what I seriously recommend is that you turn on the Microsoft or SQL account lockout functionality. So that way, if a user is typing a bad password, they eventually get locked out, because most Epicor solutions at this point rely on just a name and a password. Now, some of you have also relied on, you have to physically be present in the building in order to run Epicor, right? You don't expose Epicor to the internet necessarily. And so with account lockouts, that could mean that only people that are in the building can even start Epicor and then be subjected to the account lockout. But locking out the accounts permanently, not locking them out for 15 minutes, not locking them out for 30 minutes and then resetting, because the bad guys know that. Bad guys, if they realize that you have account lockout with reset turned on, they'll try some passwords, and then they'll wait 31 minutes, and they'll try some more passwords, and they'll wait 31 minutes. Hackers are patient lots. The average dwell time for malware in a company is 6 months. So you could have a bad actor in your company behind the firewall. Okay, now it's not an employee necessarily, although 70% of hacks do come from employees. They're just surfing around. They're just seeing what that share called payroll is. They're just seeing what they can get to. Or it could be the employee's machine. The employee visited a bad website. They got themselves a Trojan. Now the Trojan's running in your network. So without account lockout turned on, you're going to be vulnerable to the bad guys who are looking to break into your system. And with the monitoring turned on, that means you know when the account lockout occurs, you see the patterns and the trends, and you'll be able to then see if there's a bad guy who's banging on the administrator account. Speaking of the administrator account, don't use the administrator for your service accounts. Most of you have already figured this out by now, but every couple of months I run across a network where they use the user administrator, which is really bad because the bad guys know that there's a user called administrator. That's the first account that gets hacked or attempted hacking. And if you use that for your service account and the account gets locked out, guess what happens to Epicor? Stops working. So do your due diligence, create a specific service account to run your services under. And by the way, don't log in as those service accounts. I see a lot of clients, they'll create an account called Epicor 10, and they'll use that as both the service account to stand up to access the application pools, to run the Epicor task engine, Epicor search service under. Maybe they even run SQL under that service account. And then they turn around and go to the console of the machine and RDP in as Epicor 10. Why? Because it's the God account. It can do whatever it wants. However, if users are under the habit of logging in as the service account and they fat finger the password, guess what? You lock the account, that crashes Epicor. So don't log in as your service account. Maintain separate accounts for your warm-blooded administrators and separate accounts for your service accounts. Okay, so therefore, the separation of accounts where you're not going to use service accounts and people accounts also comes into play with your users. Don't be an administrator on your network while you're logged in every day doing your job, right? If you log in and you're a domain administrator and you're surfing the web and you're reading email and you are doing risky behaviors like that, if you're a domain admin as that account, any hack that you might pick up, of course, you're not going to intentionally go visit a bad website and pick up a hack, but if you pick up a hack as part of your web surfing and that program is now domain administrator, you've just compromised your entire network. So my recommendation here is to make sure that you are separating your end user surfing from your administrator work. Create separate accounts. Your end user account should not be an administrator. Create another account that you use to log in and then access the servers. The last thing you can do here is, this is not common, is you can restrict the service account location with Active Directory. If your service account is called Epicor 10, then restrict it to only logging in from the SQL server, the application servers, maybe the terminal servers, but definitely not the end user accounts. You don't want that service account being on the edge of the network where the bad guys are trying to hack in to guess the password to Epicor 10 to lock up Epicor. So again, security kind of my passion here. We can spend a whole lot more time about this, but I got some more slides, so let me move on. Okay, how infrastructure management. You need to know how your servers are connected. Most people connect their servers with Ethernet, but there are some crazy people that try and connect their servers with a WAN connection. If your Epicor server is in corporate, then your terminal server and your application server ought to be in corporate as well. There's too many latencies involved in LAN versus WAN connections. And even I've seen some clients where they put the users on the other side of the WAN to connect up to the Epicor server that is in corporate. And that sometimes you can get away with that, but typically if you're running in a WAN configuration, you're going to have a terminal server at corporate so that users don't run Epicor protocols over the WAN. They run RDP, take over a session of an RDP server, and that's typically what I see. And if you work for a larger company with branch offices, probably you've got terminal servers. If you don't, you probably ought to have terminal servers, at least currently with the way the Epicor FAT client works. Now, maybe you're running the Epicor web access or Epicor mobile access or one of those Epicor applications that was specifically designed for thin clients. P21, for example, has a P21 web client, P21 hybrid client. Those are designed for thin network pipes, and you can get away without RDP services in those environments. But notice how your servers are connected, monitor them together. Obviously, part of the infrastructure is going to be Active Directory, where you've got DNS servers and time sync that are all going to come into play. If your DNS isn't right and your time isn't right, Active Directory falls down and Epicor falls down right with it. So make sure all of that infrastructure is solid. Your AD folks should be on top of monitoring Active Directory. I have seen incredible number of clients where Active Directory isn't quite up to par, and Windows, Microsoft can be really resilient when it comes to running on an improperly tuned network. So make sure AD is up and running solid. Of course, your storage is important for your SQL servers, whether you're running a SAN or you're running direct attached storage is up to your environment, and you're going to have to make sure that your storage doesn't have excessive latencies. And there, we can go on and on about how to properly install a SQL server. Okay, so make sure your infrastructure is solid, make sure you're monitoring it. Next slide here, it talks about your application layer. Now, SQL is your database layer, and you want to make sure to manage your SQL backups. Again, the RPO and RTO of your SQL server is just as important as your application servers. SQL Server, we typically see problems in log file management. That is the transaction log. They get big because you're not doing backups. They get big because replication failed. They get big because it's that time of day. Actually, they're quite reasonable in how log files grow, but here's the key factor. You have to monitor your free disk space on a SQL server, because that's kind of the bastion of last resort. When stuff goes astray in SQL, it usually results in full disks. And there's no faster way to bring down your Epicor solution than to fill up a hard drive on your SQL server. In IIS, we have our IIS logs. By default, IIS turns on a log file. Every day you get a new IIS log, and it will fill up your disk. Again, taking down the server if it completely fills up. But they're not big log files, but they get to be many, many. In fact, a lot of times I can look at an Epicor server's IIS logs and tell you how long that server's been in existence, because there's a log file from day one, unless you're managing those log files. Also, application pool recycling. It would be great if Epicor was this really clean application that never leaked memory. And when you customize your own, when you create your own customizations, or you have custom DLLs or third-party add-ins, occasionally IIS gets bloated, shall we say, and recycling the application pool is a great way to keep that IIS server lean and mean. Only recycle it in the middle of the night when users and MRPs are not running. If you recycle the application pool, it stops all the processes. If you have an MRP running, it will kill it. So you might not be able to do this in the middle of the week. You might have to wait for your maintenance windows to recycle IIS. And some people just like to reboot their servers during a maintenance window because it keeps them lean and mean. In fact, terminal servers really like to be rebooted at least monthly, if not weekly, because terminal servers run this program called epicor.exe, and that program tends to leak memory, and it just gets muddy after a while. So, you know, Windows, where reboot fixes 90% of all problems, so proactively reboot. In addition, if you're running E10, there's this folder called Epicor Data. If you don't properly watch it, it has a tendency to get big. So look for not only its quantity, but size of all the files that are in that Epicor Data folder. If you've ever turned on Epicor application logging, this thing can get big in a hurry. So once again, monitor your application servers and make sure you're not running out of disk space. I did have a quick question here that talked about what's the ideal log file management, and that really depends on your RPOs and your RTOs. So how big should a log file get? Not as big as the disk, something that you can manage. You'll learn all about log file, SQL log files when you do your recovery and see what that looks like. IIS log files, they're typically very small files. If you never look at them, turn them off. Even if you're not looking at them and you want to leave them on, then we can share a script with you that will help you purge IIS logs after a month or a week or something like that. Same thing with the Epicor data folder. We can write scripts to keep it down and then to a manageable size. So now we've got all the applications settled. We know what our SQL is doing and our IIS is doing. We're keeping eyeballs on the server log, disk sizes and the logs. Then it comes into change management. And this is really a big challenge because change management is all about who, what, when, where, and why. Oops, sorry about that. And change management is then who created the change, what did they intend to do, and what was the unintended fallout, right? I upgraded Epicor, but I didn't realize it was going to mess with the allocation process. Your change management could be as simple as an Excel spreadsheet. It could be as simple as a notepad, or it could be a full change management application. It depends on the maturity level of your organization. But whatever you do, keep one, because you'll want to know, when I installed this patch on Sunday night, gee, all of a sudden Monday, something didn't work right. So you understand what that looks like in terms of, I did a change, and here was the intended fix, here was the unintended fix or unintended fallout. Make sure you have some kind of fallback plans. Usually with patch management, you realize relatively quickly in the testing environment that this patch did or did not work as intended. And so you have the ability to fall back. So doing full regression testing, my boss calls it quote to cache testing, just to make sure that everything works from the beginning to the end when you do an update. And that update could be a Windows operating system update. Now, patching Windows typically doesn't change how Epicor operates. It can, right? Install 13.19 and you'll see how your Epicor slows down. SQL patches don't typically affect Epicor unless they fill up the hard drive. And Epicor patches, that's really where we see most of our systems here in relation to patching, because upgrading from 10.1 to 10.2 is a significant update, and you're going to see a lot of changes in the application, some optimizations that you can make, some maybe customizations that you did before that you don't need with the newer version. So those things are need to be fully tested out. With that regression testing, what I'm basically saying is make sure that you spend the time in the test environment to go quote to cache, so you know all of the pieces that are plugged into play. Now, that can be complex. If you've got e-commerce plugged in, and you've got bartender plugged in, and you've got REST third-party programming tools, and you've got Avalara going on in your production environment, getting all of those pieces in a test environment is absolutely a challenge. I'm not going to minimize that. And sometimes keeping the test environment up to date, just keeping it kind of in sync with the production environment can be a challenge. If you need a script to copy your production SQL database down to your test SQL database, let me know. We've written that one a long time ago. We run it in our hosting model regularly. We have clients that say, hey, can you copy prod down to test? Because I got to get a fresh copy of what we're looking like in production, but I need to put it in testing so that we can play with a new module or apply a new license, things like that. Okay, so those are change management. I did have a quick, let me address your Veeam comment here. It's very shortly. I got a couple of more slides here, and then we'll open it up for Q&A. Okay, so we know that you have an option to store or where to put your Epicor solution. And it looks like that I get to, wonderful, restart my PowerPoint slide deck. Boy, how embarrassing. So there we are. Ta-da. So we understand that you have a choice on where to put your ERP system. And all I'm going to do here is to share out you have choices. Now, it could be that you are set on hosting your Epicor system yourself. Maybe you put your Epicor system in a colo. Maybe you put it up in a public cloud. There's lots of options. So when you put your Epicor server on premise, understand that you have to maintain your servers, whether they're physical servers or virtual servers. You have to buy them and license them and maintain them. You could put it up in a public cloud like Amazon or Azure. Now, most people, they look at, for example, Epicor SaaS. They run it up in the Azure cloud now. It's an option, and you basically are renting hardware resources, and it becomes an operational expense. All the accountants know that instead of buying hardware, you're now paying a monthly bill. You can put it up in Epicor SaaS, right? Epicor has been pushing their SaaS model, and that's great. It gives you an Epicor supported solution. Again, it becomes a monthly expense, not a capital expense. And you could put it up in this thing called Echo. Echo is our hosted environment that I'm personally fond of. We have a vested interest in keeping Echo running smoothly and up to date, because it's where we have both shared tenants where you can save some money by sharing resources, or we have a dedicated tenant where you can have your own of everything. So if you're ITAR or CMMC compliant, we got you covered there. And again, it becomes a monthly operational expense. Now, each of these have pros and cons. The on-premise servers, you get to buy and maintain and monitor and support the whole animal. If you're renting from the public cloud, you can come along and you basically are, first off, you're dependent upon vendor response. If Epicor is running slowly, you're calling Microsoft and going, why is my server running slowly? You're still going to support the operating system and the applications. You're still going to have to monitor the servers. And when you put it in the public cloud, most people aren't aware that there's a thing called egress charges. Microsoft makes it free to put your data in, but they charge you to take it out. Now, it's not a huge charge unless you do a lot of downloads, unless you're moving data out of that cloud environment in a significant way, and that can happen. So just be aware that public clouds potentially have egress charges. SaaS is a great solution if you can fit into their box, because with SaaS, you get free and forced updates. It's not incredibly customizable. However, one of the benefits is that the licensing for your Epicor solution is incorporated into that monthly cost. So if you currently are running on-prem and you're considering SaaS, you're going to throw away your current licenses and buy them again in the SaaS model. They build it into the monthly cost, but it's there. In the Echo environment, basically what we're doing here in Echo is we're maintaining the servers and the applications for you. Okay, not that we have to. If you'd like to be an administrator and you want to be log in with a domain, a server admin rights, and be able to manipulate the tools and the servers and the registry and the sysconfig files, you can. But what we're going to do is make sure that change management, the disaster recovery testing, the infrastructure, and all of those things that I've discussed in the previous slides, we've got lights on that. We've got eyeballs on those so that if anything happens, we have a well-oiled plan to be able to bring your servers back, to apply patches to your test servers first, and do the regression testing. If you need to help with doing the testing all the way from quote to cache, we can supply that, but we are maintaining the infrastructure for you. So there's a lot of benefits to Echo. If you're in the Echo environment, we're happy that you're there. If you're not, we'd be happy to talk to you more about that. But with that, I'm going to jump off my soapbox because I know I've gone, 7 minutes over what I should have done. Any questions for me so far? If you have those questions, go ahead and post them in the Q&A and or the chat window. I'm going to grab that sucker and bring it right over here, and so that we can see what's going on. And with that, I'm just going to turn the share back over to Cindy, so she can pop up a poll and then share her screen. But I'm going to answer the question here from one of our attendees. We have the question that says, if you use Veeam or another virtual backup solution, this is not a question, it's a statement, right? There's typically an option to truncate your SQL logs. That is absolutely true. I'm going to put a disclaimer out there, though. Most backup solutions are SQL aware. And when they're SQL aware, they back up the database and then they truncate the transaction logs. And that's great. What you need to do, though, is focus on one backup solution. Here's the caveat. I have seen users that have a Veeam solution, let's say, and then they also do a SQL maintenance plan to back up the databases, or a SQL maintenance plan to back up the transaction logs. So they've got Veeam working, and they've got a maintenance plan working. And that seems to be all great and fine and dandy until you need to do a restore, because Veeam understands Veeam, maintenance plans understand maintenance plans, and usually ne'er the tweet may meet. So therefore, if you go to do a restore, is it in Veeam? Is it in the maintenance plan? Is it on the? Is it in a BAK file? Is it sitting out on a Veeam repository? So when you do your disaster recovery testing, again, if you take nothing away from my presentation today, do your disaster recovery testing, that you're going to make sure that you know, oh, we're going to restore from Veeam. No, we're going to restore from the SAM snapshot. No, we're going to restore from the SQL backups that we did via the maintenance plan. I don't know. And the biggest problem that I've seen is when we come into a disaster scenario, because we get called in, it broke, we need you to help fix it. And what we find is that there was a plethora of backup solutions and none of them were tested. And so when it comes to recovering from that disaster, it's a mess. So please make sure that you do those testings before the fire and not after the fire. Awesome. Any other questions for me? Let's see, grab the chat line here. All right, with that, then what I'm going to do is declare a 5-minute break. And I'm going to go ahead and stop my video because you've seen enough of me. I'm going to be around for the roundtable afterwards. Be happy to answer any questions that you have now. With that, Cindy, take it away.